we will continue our discussion on cloud computing. Today we will be talking on or discussing on container or container services or containerization services, which are referred. This is an important component, and if we see in today's world or today's IT world, the overall whole a majority of the things is moving towards these containerization services, right. There are a lot of advantages as well as challenges in this sort of mechanisms, and so today we will have a overview of the thing, and then in the subsequent lecture rather we are planning to have a show you a demo of how container can be deployed to achieve a particular goal and how things works actually, right, using open source services, right. So, not today, but in this series of 2-3 lectures, one small demo will show you, right. So, this is when we talk about container, which comes into our mind is this big container which are being carried by this trailer or the trucks, and which are being shipped over from one place to another, put on the ship, right, and taken to one place to another, right. The beauty or the overall mechanism of this container, we will come to the in the context of virtualization, is that when you look at it, it looks as a box, right. It is a box which has a definite size and shape, and inside whatever is there, it is some sort of a self contained, right. So, it is carried to the other place and it can be opened or explored at the other place and work on the things, right. So, what it matters when you transfer this container is that you need to take care that it should fit into the things, whether it does not matter whether you are transferring food grains or say 4-wheeler vehicles, 2-wheeler vehicles or anything, but so long it is fitting into the things. Definitely the size of the container is made such a way that it fits over these large trucks, it fits over it sits in the carrier of the this ships, or it can be it has the crane mechanisms which can hold up to the type of container it goes on. Definitely there are other constraints like weight and etcetera, but nevertheless this type of container based things what is achieved, that a large scale of interoperability. You do not bother that what is there, what we are expecting that whatever is there inside is self contained, we do not have to give anything extra in it is transport. So, anyway that is the thing which we are having in our common things, and we try to see that how things works in this context, right. So, what we will see today is more of a container and that virtualization and container and things like that, a overview of popular open source implementation like Kubernetes and Docker services, right. So, that we will try to look at when we see this type of services. So, basically container and if you look at this virtualization, these are the keywords. So, if we just have a brief overview or a introduction to the thing. So, what we have seen, this virtualization helps in sharing resources. So, initially what we are having that server based systems where you are running more than one applications, right, and then the resources are shared, and if a application is a resource hungry, other may be starved of the resources, and those type of scenario. From there what we see in that this virtualization where we still have that infrastructure, backend infrastructure, it may be a one server or a cluster, and then we have different virtual machine. Virtual machine may have their own OS, right, they are having their own OS, over there things runs over the things. So, virtualization what it helped in share resources among many customer of cloud computing, right. So, that is one of the things what we already seen, right. So, when you talk about container, it is a lightweight virtualization technique. So, it is basically a virtualization technique. So, there are similarity in that context, and it is a lightweight technique, right. Unlike our virtualization, it takes its payload or the overall footprint is much lighter, right. So, container packages, what it tries to do, packages the code, right, whatever the code you are writing, and all its dependency. So, the application runs quickly and reliably from one computing environment to other, right. So, it packages everything, right, what you are talking about when at the beginning of this lecture, that when we talk about this what we say container in our real life, that physical container, right, what we see running over the highways etcetera by large trailer and trucks. So, what we see, that is everything is packaged inside, right, all whatever is required, it is packaged inside. So, whether you are taking it to a truck or ship or in some other things, it matters that overall its shape, size and weight, right. Other things are self contained. So, here also a container packages all codes and all its dependency. So, the application run quickly and reliably from one computing environment to another. So, it does not matter whether it is running in Linux based system, you are putting into a say Windows based system to some other flavor of Linux or Mac etcetera. Ideally, it should not matter, right. So, it is self contained type of things. So, two popular implementation or popular open source things what we are having are heavily used. One is the Docker, is an open platform for developing, shipping and running applications, and Kubernetes, where is an open source system for automating deployment, scaling, management of containerized application, right. So, these are two popular things. Rather Kubernetes evolved from means Google, which became open source exactly I do not remember, somewhere in 2014 or so. So, it is now a open source things, right. So, containers are packages of software that contain all the necessary elements to run in any. So, we are repeating just to inbuilt in our head that it is a self contained thing, right, all dependencies etcetera are there. So, it virtualizes the operating system and run anywhere, right, practically anywhere, from they say that from your own personal PC or laptop to cloud, it can run anywhere, right. From a private data center to a public cloud or even developers personal laptop, it runs in the means you do not have to do anything, everything is in means what we say encompasses in this. Containers are lightweight packages of the application code together with dependencies such as specific versions of programming language runtimes and libraries required to run the software services, right. So, to be more in a formal way, so these are lightweight packages of the application code. So, whatever the application you are trying to run together with the dependency, whatever dependency such as a specific version of the programming language, language runtimes, their libraries etcetera required to run that software services, right. So, that is the container. It makes it easy to share CPU, storage and network resources at the operating system level and offer a logical packaging mechanism in which applications can be abstracted from the environment which they actually run, right. So, what we are trying to do, like virtualization, it is basically a lightweight virtualization approach only. So, where like virtualization, it is easy, it shares CPU, memory, storage in a more efficient way and doing at the operating system level, and something logical packaging mechanisms. So, it can be from one environment in which they actually run can be put into the things. So, as we just told, offer a logical packaging mechanism in which application can be abstracted from the environment in which they run actually, right. So, you develop somewhere and how things are there, you package it as a logical packaging in the things and it can run in that same fashion. So, this so what we in effect doing this, we are decoupling the things, right. So, running of the things and where it need to run, this is now can be maintained. So, what it helps a container based application to be deployed very easily, right, because you do not have to break your hand in reconfiguring etc. And consistently the way it is running in one deployment, other deployment consistently, regardless of whether the target environment is your a laptop or PC or cloud etc. So, overall what it the basic it supports this agile development, that is one of the need of the things, right. We require agile development from the developer point of view. Containers allow developers to move much more quickly by avoiding concern about the dependency on environments, right. So, it is a possible to have agile development. Efficient operations, containers are lightweight and allow to use just the computing resources one need. This running of the application, thus it basically run the application in a very efficient way and run anywhere, as we tell that it is a basically along with the your application, all these dependencies etc. there, it virtually runs anywhere. So, whatever platform you are put in. So, if it supports this container, it supports your the application. And of course, in we can see that from the previous discussion, there are several benefits, right. One is separation of responsibilities, right. So, we can containerization provides clear separation of responsibility. So, it is a so developers focus on application logic and dependencies, IT operation teams focus on deployment management instead of the application details etc. etc. So, so the developer is more concerned about the implementation of the logic, whereas the this other team or the core IT team or deployment team, they are more concerned about this the deployment management, and then it is they are not bothered, because once it is containerized they know that things are is going to be in this fashion, right. So, what we are, if we again come go back to our analogy, when we are transporting something over a fixed container over the truck etc., the other end that the shipping company is not actually bothered about what it is coming. It understands that whatever is there, it is self contained, and a box of this size and this weight is coming, right, of say this size and max this weight is coming, and we need to fit it into somewhere, right. So, it is they can work on their domain separately, right. Workload portability, another another major benefit, that container can run virtually anywhere, greatly easing development and deployment, right. It can be on Linux or different variants of Linux, it can be on Mac, it can be on Windows. So, it either on a VM or a physical machine, on a developer's machine, data center on premise and public cloud etc. So, it is a enormous portability it keeps, which is one of the major challenge in today's world, or rather major challenge in IT world for from the beginning itself, right. Like if I want to transfer a application or a bunch of code from one to another, then there are serious challenge of portability. So, it tries to address that issue. So, highly portable, and it becomes very what we can say, it becomes very extremely useful, and when we deploy something at the, you want to deploy something at the customer end, and where you do not have that expertise of make these tools and packages, you need to reconfigure at your end the system etc., right. So, if you have this sort of a container based services, then you do not bother about this, you just only bother to how to house this container, and if that is standard, and then you do not bother. So, once if it is housed, things will run, right. Application isolation, container virtualized CPU, memory and network resources at the operating system level, as we discussed, right, few minutes ago, providing developers with a view of OS logically isolated from the other applications, right. So, it gives some sort of a whatever is there, it is basically having a isolated from other things, right. So, it is something which is there on the for its own purpose only, right. Again, not a very may not be very good analogy in this case, but if I think that my container I want to ship something, say I have a car company and to ship the cars. So, I only bothered about that how it fits into the things, right. So, it is all my things, I do not care that whether it is separately transferred, how it is transferred, whether to or how many modes of things are transferred. What I am bothered about that how my things will fit this thing and how means what are the way I need to deploy that inside that container, right. So, what we see separation of responsibilities, workload portability and application isolation, these are the major things which are serious challenge, right, in any IT industry or deployment of the things. So, if we look at the three pictures, so to say, so this is our traditional deployment still there. So, or maybe slowly we are moving to the more of a virtualized world, right. So, this virtualized, so in the traditional we have hardware, operating system and apps over it, right. In a virtualized deployment, we have that infrastructure or the hardware which can be cluster of systems, over there the operating system, then the hypervisor or the VMM virtual machine monitor, and then we have different virtual machines and then run their that guest OS on these virtual machines and run applications. So, initially the hardware which are not shared among the resources, now it is properly shared, right. Here also the application share these resources, share the hardware resources in traditional, but there is no boundary between them, appropriate boundary. So, in that case what will happen that some require more resources, may resource hungry application may eat away some of the things which are other as serving, etc. There are issues of isolation and there are challenges of security and things like that, those things are there. And when we come to the container deployment, then we have hardware, operating system and the container runtime. Over that we have different containers, right. So, they are self contained, they whatever the application etc. is there. So, they are self contained and run on this type of things, right. So, this three things. So, just to what we discussed, this traditional deployment, applications run on physical servers. There was no way to define resource boundary for applications in a physical server like this traditional server, and then this caused resource allocation issues, right. As we are telling that some may be eating away more resources than the others and things like that. Then the next thing is the virtualized deployment, allows to run multiple virtual machine on a single physical infrastructure or the physical say machine, right, one or more things. So, physical server CPU virtualization allows application to be isolated between the VMs, because there are isolations. It allows better utilization of the resource in a physical server and allows better scalability, right. So, one is that application isolation, and I can scale the things, like I require more VM resources, then I can migrate and things like that, I can do different scalability. Each VM is in a sense is a full system, right, required for the customer or the running application, running all components including its own operating system on top of virtualized hardware and etc., right. And the next gen sort of thing what we are seeing today, or what it is this IT world is going towards, is the container deployment, right. Containers similar to VMs in case of virtualizations, things like that, but they have relaxed isolation property to share the operating system among the applications, right. That is another part. So, that therefore, containers are considered lightweight, containers has its own file system, share of CPU memory, process space and more. The containers are decoupled from the underlying infrastructure. They are portable across different cloud service providers or different OS distribution and things like that, because as they are decoupled from the underlying infrastructure. So, they do not have to be there. So, this things portability is much higher, right, than VM, and rather in case of a traditional portability is a serious challenge. So, now as these containers and VMs are going hand in hand, instead of telling that containers versus VM, let us put it as a container and VM. Like so, VMs, a guest operating system such as Linux and Windows, run on the top of a host operating system. So, as we have seen in the previous picture, so there is a host operating system and a hypervisor, and there are different guest operating system which runs over that. The underlying host hardware, right. Containers are often compared to virtual machines, obviously, because both are virtualization techniques. Like virtual machine, containers allow one to package of the applications together. So, it allows us to package these applications together with other libraries and dependency, providing isolated environment for running the software services. So, what it allows? It allows the package the application together with the libraries and other dependency. So, it is not it is self contained, right, and thus providing isolated environment for running the software services. So, however, what we see, so rather in a sense this is also somewhat is also true for other VMs, but in case of container offer a far more lightweight unit for developers and IT ops team, operational team to work with, carry a myriad of benefits and etc. So, it is practically, if we compare with the VM, one of the thing is that it is extremely lightweight. So, what if we see containers are much more lightweight than VMs, that is one thing. Containers virtualize as the OS level, while VM virtualize at the hardware level, right. Usually, virtual VMs virtualize at hardware level, where container virtualize at the OS level. Container shares the OS kernel and use fraction of the memory required, right. So, it use the exploit that OS kernel and use a fraction of the memory VMs required. So, in comparison to the VM. So, that is what we see, it is a lightweight virtualization technique what we looked at. So, now let us look at to popular overview, we will little look deep into the things in the subsequent lectures. One is Kubernetes, right. Kubernetes is a portable, extensible, open source platform for managing containerized workload of services that facilitate both declarative configuration and automation. So, one sentence tells a lot of things, right. So, it is portable, extensible, open source platform for managing containerized workloads and services. So, it basically able to manage containerized services that facilitates both declarative configuration and automation. So, it can facilitate your declarative configurations of the things and automation. So, it has a large rapidly growing ecosystem, so to say. So, it is a big thing what is the containerization is going on. So, Kubernetes services support tools are widely available. So, that is widely popular and it is open source. So, what it says that literature says that Kubernetes originates from a Greek meaning some helmsman or pilot, right. Anyway, that is the why the name like that. Kubernetes operate at the container level rather than at the hardware level. So, it provides some application features common to PaaS offerings, right, like platform as a service, right, where it is higher than the IaaS type of things. So, some sort of a patch covering such as deployment, scaling, auto balancing, and lets user integrate their logging, monitoring and alerting solutions, right. So, it is not at the hardware level, but can be thought of at a something as a PaaS level. However, Kubernetes is not monolithic. So, that these default solutions are optional and pluggable. So, it is not a monolithic structure. So, these are optional and things. Kubernetes provides the building block for building developer platform, but preserves user choice and flexibility where it is important. That means, it both provide building blocks to for the developers, but also give a choice flexibilities of the user things, right. So, it is a what we say, it is a more versatile service which is much lightweight and have their building blocks and also give. So, we will see little bit of Kubernetes in subsequent lectures. So, if we look at the Kubernetes components, so so when we talk about Kubernetes installation, it provides you a cluster, right. So, Kubernetes cluster consists of a set of worker machines called popularly known as nodes that run containerized application. So, these are the nodes which run. Every cluster has at least one worker node, means there should be any cluster should have only at least one worker node. The worker node or nodes host the pods that are components of the application workload, right. So, these worker nodes basically host the pods which are basically application workload components, right. There is a control plane manages the worker nodes and the pods in the cluster. So, there is a cluster where the worker nodes are there, which worker nodes host the pods which are the components of the application things, and overall things are managed by this control plane which both the worker nodes and the pods. So, in the production environment, the control plane usually run across multiple computers and a cluster usually run multiple nodes, right, providing fault tolerant and high availability. So, it is typically in a production environment what we say that the control plane runs over multiple computers and a cluster usually run multiple nodes which host different pods and it provides a fault tolerant and high availability. So, this is a big picture of the Kubernetes where these control plane things are there and there are different nodes, and if you look at there are different other components like scheduler, kube proxy, kubelet, etc. We will discuss those components in subsequent class. Another popular open source platform is Docker or sometimes called Docker container. So, name is something which can be docked and docking type of things. So, what we have seen, Docker gives a sandbox process that is isolated from all processes on the host machine, right. So, it is a mechanism by which it is isolated from the other processes. Container is a runtime instant of an image, right. One can create, start, stop, move, delete a container using things like Docker API and CL or CLI and type of things. The container can be run on local machine, virtual machine, clouds and anywhere, right, that we have already seen. So, Docker again will discuss like Kubernetes with the Docker also little bit more. So, just to give you an overview, the Docker container image is a lightweight standalone executable package, right, software that includes everything needed to run that things: code, runtime, systems tools, dependencies, libraries, settings, etc. everything, right. So, this is very popular and becomes very handy for easy deployment and things like that. So, container images become containers at runtime, right. So, we have container images which becomes container at runtime, and in case of Docker container, image become containers when they are run on the Docker engine. So, there is a concept of Docker engine over which these things runs, right. So, available for both Linux and Windows application. Containerized software will always run the same regardless of the infrastructure, right. So, that is the basic things what we started with, right. Regardless of the infrastructure, it can run anywhere and in the same fashion. Containers isolated software from its environment and ensure it works uniformly despite the differences in the operating systems and different instances of the development and things like that. Okay. And if we look at that this Docker engine, so run on Docker, this container run on the Docker engine, it is standard. Docker created the industry standard, and the containers, they could be portable anywhere, right. It is lightweight and secure. Applications are safer in the containers, and Dockers provide the strongest default isolation capabilities in the industry. But the Docker, they claim that they are, I think, nevertheless, it both this containers try to provide this isolation, application level isolations, which helps in different what we say, securing the application from other applications. Okay. With this, what we see in today's class discussion is that what is a overview of the container. We rather few lectures or sometime in the previous discussion, we discussed about Dockers and containers, but this time we in next couple of discussions we will be having going little deep into the things, and actually want to show you actual deployment of this sort of a container services and how things works in this type of environment, right. So, with this, let us conclude our things. There are few references like Kubernetes and Docker and some from the Google Cloud things. So, you can refer those documents and things like that. So, let us conclude here for our this basics of or overview of the container or container based virtualization. Thank you.